Hello, I am Anne Wine with the United States Geological Survey. This talk about communicating aftershock forecasts has broader implications for any protracted hazard or risk communication. The study was a collaboration with New Zealand researchers at Massey University, Canterbury Innovation and Earth Sciences, formerly GNS Science, to learn from the Canterbury earthquake sequence in New Zealand. When a large earthquake occurs, many more follow. The map shows the Green Star main shock in a rural area of Canterbury on September 4, 2010, and thousands of aftershocks that trended east through the city of Christchurch. The magnitude 6 aftershock, 6 months later, was, unfortunately, the most damaging and fatal earthquake in the sequence due to its location near the city centre and time of day. The cumulative graph of aftershocks shows the large earthquakes reinvigorating the seismic activity. It does level off with time. And above, the time series of aftershock magnitudes shows spikes of earthquake activity over time. Imagine living and working in this shaking environment. We can not only look back on an earthquake sequence, but also forward to help people understand what to expect. We know the statistics of earthquake sequences within regions and can forecast how many may occur of what size within a day or a week, month, year. The graph shows a grey band of uncertainty around the number of magnitude 5 or greater earthquakes that were expected the next day. And then this forecast was compared with the actual observations in yellow stars. Again, we see an earthquake sequence slowing down over time, although it may be a bumpy ride. The bar chart is another example of an aftershock forecast from the USGS, showing the probability of at least one aftershock within the next year for each magnitude earthquake from magnitude 3 to 7. So smaller earthquakes would be felt and are very likely, but the less likely magnitude 5 or 6 earthquakes would cause the damage. So almost 3 years after the initiation of the Canterbury earthquake sequence, we conducted the first study of the communication of aftershock forecasts with multiple decision makers, including critical infrastructure, politicians, communicators, emergency responders and managers and scientists. And unsurprisingly, scientists declared more knowledge of aftershocks than the public and politicians before the earthquakes began. From the experience of different types of decision makers, typical best communication practices were affirmed. In other words, communicate using multiple formats of text, tables, graphs, maps that are suitable for different channels of communication. Although technical forms of the forecast are used by scientists and engineers, many others need simpler versions coupled with advice on action and with empathy for the unsettling experience of this earthquake sequence. It helps to coordinate the message across the authorities on science, protective actions, and coping. The highlighted challenge was communicating the risk of those large damaging earthquakes that have the lowest likelihood of occurring. Because recall, the most damaging earthquake did happen 6 months into the earthquake sequence, by which time people thought they had feared the worst. At the USGS, we built what we learned from this study into our aftershock forecast template that opens with non-technical and important information to be ready for more earthquakes. The template offers a detailed description and tables of numbers and probabilities and other technical information in the tabs. Now here's what the tables may look like for forecasts of numbers and probabilities of aftershock magnitudes, and engineers readily can use these tables. For example, in May 2011, there was a very high probability, 99% of a magnitude 5 aftershock or greater within the year in the region shown in the map. and then the forecast numbers go down with each day. In other words, more earthquakes likely sooner than later. Given the earthquake activity, the probability of a magnitude 5 or greater earthquake went down, 4.5 years later, but it was still at 50%. What would you think and do about this information after 5 years of earthquakes? Well, with the flip of the coin, the magnitude 5 aftershock occurred on Valentine's Day in 2016. So the earthquake caused cliff collapse as well as other damage. Fortunately, damage to the built environment was limited after the demolition of unsafe buildings, new construction and new zoning. So since the beginning of the earthquake sequence, there were also population shifts as some people who left the region did not return and new construction workers and residents moved into the area. So this brings us to the research question of our 2016 study. Given the changing landscape of people, place and hazards, what can be revealed about aftershock forecast information and communication needs from investigations of the long-term experience of the sequence? At the time, there was very little literature to be found on communicating about an evolving hazard over years of time. The closest cousin were a few studies of communications of volcanic unrest. For example, Haynes and others found that information and communication needs were affected by various dynamics of hazard, of relationships and trust between scientists and decision makers, and of political influences. So although we had collected our data before the COVID-19 pandemic, we had not completed the analysis, and the pandemic spurred a longitudinal risk communication research agenda and other studies that we could then relate to. We collected our data in workshops with 8 emergency managers, 6 public health officials, and 7 informed residents. It was more difficult attracting participants compared to the earlier study when people were still feeling the effects of the earthquake. The topics discussed were the participants' experience of the Valentine's Day aftershock, 5.5 years after the whole sequence began, information needs as they changed over time, and feedback on aftershock scenarios, which I will elaborate on in a bit. We analysed transcripts of the workshop discussions. We identified themes of surprise about the Valentine's Day earthquake. That was a coin toss of happening within a year. Themes of various dynamics of risk perceptions, preparedness, trust in the science, information needs, coping with uncertainty, and the feedback on our scenario forecasts. So under the surprise theme, the participants became aware of how the population had diverged on risk awareness and coping. There were those that were not surprised by the aftershock as they had retained the concept of a decaying earthquake sequence with spikes of activity. They said the actual time, location, and size of the Valentine's Day earthquake, of course, was not known. There were those that said they set themselves up for surprise because they'd become less attentive to earthquake risk and moved on with their lives. People were feeling safer since dangerous buildings had been demolished. However, this lack of surprise and concern amongst seasoned populations resulted in an underactivation of communication responses from emergency managers. And this resulted in a communication gap for those who were upset because they were new to the area or were re-traumatized. So furthermore, reduced attention and concern, plus newcomers working in the hospital, resulted in a lapse in hospital response procedures because they had not been practiced. In the long-term communication context, we sought feedback on an alternative form of aftershock forecasts as scenarios that describe three possible sequence behaviours going forward from the Valentine's Day earthquake. So the first was the most likely, and that there would be a steady decay of the numbers of aftershocks. The second sequence, though, involved another damaging aftershock with a 27% chance. And then the third, which was least likely, but still possible, and trying to emphasise the impact of the larger earthquake, was one that was an earthquake at least the size of the main shock occurring within the sequence. The feedback on the scenarios aligned with a pandemic sort of future outlook that was put out by McKinsey and Company, and that being that the communication of uncertainty is important for trust in science, and one way to do that is with 3 scenarios, including a worst case, and 3 is a good number. And using a layout that shows that one of these may happen, that was less clear from our text form. Also, to try and visualise some of the impacts, and in this COVID-19 example, the impacts were shown as curves of hospitalisations, which were either sort of below or on or above the middle scenario. And finally, to provide a scientific explanation of why there could be 3 different scenarios. And again, in the COVID-19 case, that was explained by immune evasion. What did we learn? First, communications about earthquake sequence behaviour aided sense-making throughout the sequence when people first heard it. The descriptions of earthquake sequences' spikes of activity were helpful in knowing when they happened, or knowing it was normal behaviour of a sequence. Second was appreciating that we are communicating to a population with divergent experience and information needs. For example, information needs have broadened from some needing to understand an earthquake and an earthquake sequence and receive emotional support, to others needing reminders and understanding of residual risks that are still remaining for continued preparedness and response, and others needing less information about the current sequence and more about larger earthquake risk from sources further away. So the communicators recognise that they should have messages for multiple audiences at the ready. And third, that under-activation of response communications and lapse of hospital response procedures prompted requests for strategic forecast updates from the trusted scientific source as reminders to maintain their preparedness. Although this is stated in retrospect, and we don't know how they would have been received, aftershocks can still be built into earthquake preparedness exercises instead of a singular focus on an earthquake, which is what most people told us that's all they had ever exercised, was just the one earthquake. Fourth, communicating uncertainty of the forecasted numbers of aftershocks or aftershock scenarios may help people accept and tolerate the uncertainty. There's less about this in the literature, and sort of understanding what information helps with that. We know more about sort of communicating uncertainty for the importance of building credibility of the scientific source. And then fifth, developing our capabilities to provide impact-based forecasts. What could still happen? In addition to providing preparedness actions. This would make the information more actionable in decision-making. With this slide, I'm going to reiterate some of the points, but show how they apply over a cycle of communicating about earthquake sequences. There's some other points on here in the lighter text pertaining to how risk perceptions may change over time, which is an important context to understand, but I've not really gone into much depth about that in this talk. So I will illustrate sort of that communication of aftershock forecast thread over time. So before an earthquake, we can start out by talking about earthquake sequences. New Zealanders were adamant to stop talking about an earthquake. And again, we can build those aftershocks and forecast of them into readiness activities. Once the large earthquake occurs, it's important to know there will be more, and also to link that forecast to the earthquake notification, which has since been done at USGS for domestic earthquakes. Now, in between the larger events in the sequence, we found a need for reminders of the residual risks, like the cliff collapse. But there is a balance because people are trying to get on with their lives. But it's important to remember that the number of earthquakes is still elevated, and to support ongoing preparedness activities and preparedness for new residents and workers in the area. And then after the large aftershocks, a communication response is still needed and needs to be coordinated, remembering that there are new or re-traumatized people affected by what has just occurred. And again, at this point, it still made sense to reiterate earthquake sequence behavior because some people were still hearing it for the first time. To thread together the information and needs shared by our participants, we pulled from literature in these areas, the psychological and behavioral sciences, psychological adaptation, where there is decreased concern about hazards over time and exposure, atrophy of vigilance relating to lapses in preparedness, and living with uncertainty and the type of information that helps with that. We look into literature on hazard forecasts, impact-based forecasts largely led by weather forecasting, real-time hazard scenarios to really be able to better communicate the risks and the collaborations needed for those capabilities. And the third area was more standard hazard and risk communication literature, communication of uncertainty, and understanding dynamics of trusted sources over time, coordination of messages, from across scientists, emergency managers, and public health officials, and also the social amplification and attenuation of risk regarding the lack of communication response through the networks after the Valentine's Day earthquake. All of this and more is detailed in our paper in the International Journal of Disaster Risk Reduction. We identify research needs and operational capacities to further long-term communication of aftershock forecasts. Sally Potter of Canary Innovation created an accessible version for practitioners in a blog. Sally was the one who laid out that cycle of communications from our studies. So many thanks for your attention, and I hope it's useful to think through the risk communication of hazards and when they can go on for a while and change in their nature and severity over time. Thanks again.